Hey Techno Studs, Layer 4 is where ports come into play. So there's a lot that happens with ports, and it's pretty prevalent whenever you're talking about networking. So it's important to have a good grasp and understanding about ports and how ports are used for communication and how they address certain services. So we're going to take an in-depth look at ports. First of all, what we're going to talk about is what is a port. We'll talk about some port groups and how ports are divided into different groups. And then we'll talk about port security and how there are some aspects that you got to consider when you're talking about when you're talking about ports and ports being open on your computer. Then we'll talk about what a socket is and what the socket looks like. And then we'll finish things off with ephemeral ports, or ports that are used from the source port is really what that is. To understand ports, let's recall what the client-server relationship is. So a client is a machine that's going to be asking for some sort of services, and a server is what's going to be delivering those services. So let's give an example as maybe we're dealing with a web page here, and this client machine is going to be asking for services or asking for the web page, and the web server is going to be delivering that web page. So the client machine is going to send a request to that server asking for some sort of service, and in this example would be a web page. But how does, when it gets to this other side, how is that request going to look? How does that machine know what the web page it's looking for? Maybe it's serving up multiple web pages, or maybe it's serving up multiple other services like SSH, or maybe it's a mail server as well. So this server could actually have a lot of different services on it, and so we need a mechanism that allows this computer to address a specific server or a specific service that server has on it. So we do that through ports. Ports on your machine could be physical. You could have a physical port like a USB port or a serial port, or some sort of port on your computer where you plug devices in and then it establishes that communication. But when it's being sent across a Ethernet cable or from outside of your network, when it's being sent across to the server and connecting into the server, then how does that server know what you're trying to access? And we do that through virtual ports or virtual connections. And so these virtual ports, or we just call them ports out there, are numbers. And so we have a lot of different numbers that we can use that we will associate these ports with certain services. For an example is port 22 will be associated with SSH. So when it's connecting into port 22, then it's connecting into port it's trying to access that SSH service. So in this example right here, we have a server, and that server has several different services that are running on it. So we've got an SSH server, we've got a SMTP server, we got an HTTP server, and maybe multiple instances of HTTPS, or so we have these different services. So this HTTP and HTTPS, those are all just web pages maybe that this single server is hosting out. So it's hosting out multiple web pages here. So then when a connection is established on one of these ports, so let's say a request is coming into port 22, then it knows that it's trying to access SSH. And we could have multiple SSH services running on this server as well, or multiple SMTP services. But in a lot of cases, we usually just have one port that's associated with that service. But as an example, here we've got multiple web pages, and they're each being hosted on a separate port. And we can do that. We can assign these different ports to these different web pages, and that could be one way that we could host many different web pages from one server. Now, that's not typically done with ports. There are other ways, so that way we can maintain all the standard ports, and we'll talk about standard ports. But it is an option for us to do that, is to associate all these different ports with these different services and host out different web pages, different websites, depending on what port you're trying to access. So this is one way, once again, where this server is hosting out a lot of different services on it, and those services are associated with some sort of port. And then those ports are addressed by the client that's coming in, is going to make a request based off of the port that it finds within the TCP header. So here's another example. This one looks more like a mail server to us. So we have SMTP port 25, POP3 110, IMAP 143, SMTPS. So these are all mail protocols that are used on the machine. And so these are connections that we can establish depending on what we're trying to do. Are we trying to download mail? Are we trying to upload mail or send mail or receive mail? Are we maybe trying to access, rather than using a client to access our mail, maybe we're trying to get in and use the web client to access mail. So port 443 may be open on this machine, so we can use web access to our email. Or, I probably can guess that this might be a Windows machine, because port 3389 is open on that machine, and that's commonly associated with RDP, which is RDP is what Windows uses, what you use a lot of times to connect connections to a Windows machine. So by knowing which ports that are open on this computer here, or this server here, we can probably make some guesses on what type of machine or what type of services are running on this server here. So here are some port numbers and how they're grouped up. So in this first example, the first 1024, ports are associated with well-known ports. And so we have well-known ports. And then the second grouping of numbers are registered ports. And then the third one are just dynamic or private or ephemeral ports, ports that you can be assigned anywhere. And so this is all set up, and the Internet Assigned Numbers Authority is the one that manages all of this. So what would be some examples of this? Would be these are really well-known, often used ports that are associated with each other. And so an example of this is port 80 is associated with HTTP. And so what you'll see is if there's port 80 is open on the machine, then that's most likely HTTP. And you wouldn't really want to associate another service with it. You wouldn't want to associate like SSH to port 80. You could, but that's not typically that's done. So these port 80 is generally associated with HTTP. You wouldn't want to probably assign another service to it. There would be some reasoning why you would set HTTP up to be on another port rather than port 80. But generally speaking, this is a one-for-one where port 80 is associated with HTTP on that port. And so these are well-known ports, and you don't really mess too much with these well-known ports. You kind of keep those intact and follow the standard out there. If you were to associate HTTP with another port, like let's say you associate with port 8080 instead, then what could happen is that you're making your users jump through one more hoop to enable to get to your website. And if that's the case, that's fine. Maybe you're doing it for some sort of security purpose, although there's questionable on how secure that actually is. But so anyways, with this, there's these general associations. The registered port then is if you're a company and you have a product that's pretty widespread out there and you want to devote your port to your product, then you'd go and you'd register that, and you'd register it once again with the Internet Assigned Numbers Authority. So you go to them and you say, hey, we got this port, we want to assign this port, and you go through some paperwork so that way you could register this port. So a lot of different places out there, organizations out there will register their product and get their ports. Do you have to register those ports? No, you could still take up one of these ports and utilize it for your purposes, and it's not registered at that point in time, and there's not anything that's terribly wrong with that. Then you have these dynamic or ephemeral ports, and we'll talk about ephemeral ports and how these ports are used a little later on. But these are some of the common group ports. Like I say, you probably want to leave this first range alone. So that is you want to leave that service associated with that port, and you wouldn't want to assign another service with that port within that well-known port range. But outside of that first range, there is a little more freedom that opens up when you get into these other two groups. Now, it used to be when you first install your operating system onto your machine, there's a bunch of services that were automatically up and running. There still actually is. There's a lot of services when you first do an install on a machine. There's still a lot of services that are up and running. But by default in the past, there were extra services that were up and running. What this did for you is it made it a lot easier to set up services, get them running, get them functioning, and things could be taken out of the box and already work to a certain degree. So maybe you take it out of the box and it already had some email forwarding capability and it had some other things that were set up on it. And this caused problems because for every piece of software that you have operating, that is one more piece of software to patch, that's one more piece of software to get out of date, that's one more piece of software that has vulnerabilities on it. And so it opens up your box, and somebody could potentially leverage that to get access to the rest of your box. So in this example right here, we've got some some email applications and some web surfing, and we've got RDP that's opened up on this. And so with these different components that are open up on here, there could be a vulnerability within RDP that then can be leveraged for these other protocols to take advantage of these other protocols and take over the box, or vice versa. Maybe these protocols expose something, some sort of flaw in RDP. And so you open up your box for more problems, the more services that you have up and running on that box. So initially these came to you by default, all set up, ready to go, with these basic packages already installed. So that way is more plug and play. But the flip side to that is then your box was more vulnerable. So what you would do is you go through this hardening process and take any of those services off to make sure that you weren't opening up your box for more risk than what was necessary. You only opened up those services that you needed to open up. Now, we've learned from that mistake of doing that, and so now we have less services that are on these boxes, but we've made it easier to turn on those services if you're going to utilize them. So the box comes to you, it doesn't have these services automatically up and running, but it's it's a little wizard that you step through and say, hey, I want these services, then it installs it on your box and opens it up at that point in time. So that's a little bit about ports and port security. You do want to be concerned about just opening up all these different ports and all these different services on the box, because that can open up potential vulnerability and expose that box to things that you don't necessarily want to expose it to. Okay, another aspect to port security when it comes to port security is using non-standard ports for certain services. And there is an element of security with this. So in this example right here, port 22 is associated with SSH. But if we were to change that to a different port and we said we're going to associate on this box 42,515 with SSH, then what will happen is that now your devices that you're connecting to this, you're using a non-standard port, and you have to specify what port you're using to connect to this box. And so we call this security through obscurity. And in the security realm, we don't really consider this any more secure, because anybody can still do a port scan on that box and figure out that this port is open and it's open to SSH, and still can use the same mechanisms to hack that box. And so it's in the security realm. Security through obscurity is not really thought of as being secure at all. However, there is an element of security involved in here. And that is because there's a lot of things that will just do automatic scanning and look for the low-hanging fruit. And so they're just trying to hit port 22 or some of the common ports on boxes just to see if that's open. And if it's not, then they go on to the next one. And they're just hitting a bunch of different boxes. And so in that scenario, your box is not going to be hit as much if you turn it to a non-standard port. The other thing that this corrects for too is if we have our firewall that's open to port 22, you're going to get a lot more traffic that's going to that box. But if that is shut off, then all that traffic never gets to the box. If it's going to port 42,515, all that traffic's getting stopped now at the firewall, and there's very few things that are actually going to try to attack that port, SSH on that port. So there is an element of security if you're taking a service and assigning a non-standard port to it. Although don't consider that as being the end-all, be-all secure method of locking down the box, because it's not. And if that's the only mechanism that you're securing your services through, then that is not secure at all. However, it is a stepping stone that you could do to limit the amount of traffic that's actually hitting that box and limit the amount of people trying to hack into your box, because a lot of them out there, once again, are just looking for low-hanging fruit. Now, the disadvantage if we're using non-standard ports, let's say now we're using 42,500. Well, let's go back to port 22. If we're using a program that to SSH into port 22, and that SSH program, let's say we're using PuTTY in order to connect into a box. That program, you don't need to specify that it's port 22. It just automatically assumes it's port 22. So if you're accessing now port 42,515, we actually, at the end of the IP address within PuTTY, have to put a colon 42,515. Not a huge deal. Once again, adds a certain element of security to it. But the disadvantage is that we do have to specify that. Not a big deal if we're talking about SSH, because we're probably not opening this up to the whole world and everything. But if you're talking about something like port 80, which is associated with HTTP, and you're making your users, let's say you changed it to port 8080, and you're making them put colon 8080 at the end of whatever URL they're typing in. You know, they type in a domain like www.google.com colon 8080, and that's what they have to use to access google.com. You're probably going to get less traffic going to google.com. And so that's why we have these non-standard ports, and we associate that traffic, port 80, with HTTP. Now there's this idea of something called a socket. A socket is what we're plugging into or getting into this box. A socket is a port combination, really. It's a IP address and a port. Those two create a socket. So here we have an IP address colon port. That is a socket. And so that is addressing a specific service that is on that box. So the IP address is the network interface IP address, and the colon 22 probably means that we're connecting into SSH in this example, and we're making a connection into SSH. So a server could have several sockets that are open on it. It could have, if this is the IP address, 192.168.45.145, and we have colon 22 open, colon 53 open, colon 123, colon 389, colon 636, and colon 4434. So all of these different services now are open on this machine, and each one of those is a socket. Similarly, on that network interface card that's coming into that box, we could have several different IP addresses that are associated with it. And so any of those IPs, any packets that are destined for any of these IPs, .145, .146, .147, .148, will make it to this box. And in addition to that, maybe then there's some sort of port that it's addressing, so 443, and that's associated with HTTPS. And so any packets that are destined for this one right here is going to be associated with HTTPS. Now, why would we do something like that? Well, in this example right here, these are going to individual websites, and we specify an individual website for each one of these IP addresses, and they're all have HTTPS connecting with HTTPS. Now this box can host, in this example right here, 4 different websites, and it associates what you're trying to access based off of the IP address that it's trying to access. So this is, once again, different sockets, how we can specify different sockets so we can access a specific web page. Now, I would say that probably this is the less desirable way to access a specific web page. There is a way to access specific web pages using host names rather than the IP addresses, and this allows us to not have so many IP addresses for all these different web pages. So there are other mechanisms to do the same thing. But for this example right here, I'm driving home the point of what a socket is and how as a packet comes in, how can address specific services, or in this case, specific websites that all use the same service, and it can do that by using multiple IP addresses. So we're not limited. There's lots of different combinations we can do with this. So this box right here has lots of different sockets that are open to it. We have 192.168.45.145:22. So we're probably talking SSH there. Then we have a website, port 80 is open, so HTTP. Then we have 145, which is colon 443, which is HTTPS. So we have a website that we're hosting there. Looks like we may have a few other websites that are being hosted on these, and each one of these is a separate socket. So we have, in this example right here, because of the port combinations and the IP combinations, we have 6 different sockets that are open up on this server. Now, one thing to note is that we try not to really use port 80 anymore, even if it's not a website we are concerned about security. We still don't really open up port 80. An example of that is if you go to http://www.google.com, it will redirect you to a secure connection because port 80 is no longer considered secure, and we redirect that traffic to a secure connection. And not that we're too concerned about with Google itself and that website that is being transferred back and across, and not too concerned maybe with people looking up what we're looking up, so we don't really care if we use HTTPS or not. But it could be that if there's somebody in between that was capturing that data and sending different data to your computer, then they could leverage that and be able to make you think that you were on other sites that you weren't, and then start doing phishing campaigns to get information. So there's a bit of a security concern there. Even with websites that we don't typically think need to be secure, there is a security concern. So we still now, what the best practice is not to use port 80, or if you're going to use port 80, redirect it to port 443. Now there is one scenario here we haven't covered yet. We talked about how a server could have lots of different services, or even the same server or same service that's being hosted out, but different sites that it's hosting out. So this server could be doing lots of different things. But what if the scenario is you're just trying to access one of the websites, but you're trying to access it multiple times? I do this many times where I'll have multiple windows that's open, or multiple tabs that are open that's accessing to this same website. And so in that scenario right there, we are addressing a specific socket on this server, but we're doing it multiple times. So then the question is how does this server know that it's fulfilling each one of these requests and fulfilling it separately? And we do that with what's called ephemeral ports, or ports that are on the client side. So as we take a look at what's in the packet, we'll notice that there is a source port and a destination port. And we've been up until now really addressing the destination port, where we're trying to go to. But there is a source port, and the source port, let's say this is 2048 is the first port right here. And then next, and that's the first request. So that's the source port for the first request that comes over to the server. And the server is going to then track this IP address and this port in its reply as it replies back. So then it knows which data it's sent already to this machine right here. And then the next time we request a web page from that same site, then we're going to increment that up, so 249. And so it makes the request with a different source port. That's the important part of this. It's a different source port. It makes the request. And so this server right here sees that as being a different IP address / port combination or different socket. So it's a different request, and it will fulfill that request separately. Now we open up another tab on our browser, access the same site. It's going to the same socket over here, but this socket on this side needs to be different. And so it's a same IP address, but it's 2050. It's the next source port. So those source ports are called ephemeral ports. They're ephemeral ports. They're on the machine. They are separate virtual ports. They're coming from the source, and it's used to track the conversation, this TCP conversation that's happening back and forth. So really, there's a socket on both sides. There's a socket on the client side, whatever's requesting it, and the socket, remember, that's the IP / port combination. And there's a socket on the server side, which is once again the IP / port combination. And the IP / port combination says what service it's going to access, but the IP / port combination on this side is to keep track of the conversation to make sure that that this server can actually fulfill multiple requests from the same client. So those are ephemeral ports. All right, let's recap that one more time to make sure that we understand that concept. So we have a machine over here that's 10.40.40.15. It's trying to reach the server, which is 172.16.43.4. What's going to happen is it's going to be addressing a specific service. So let's, in this case, say it's port 443. So this is the socket on this side that it's going to access. And we know that it's 443, so it's probably HTTPS, probably some sort of web page that it's trying to access. So that is the socket on this side. Then on this side, we have the ephemeral port that comes into play. So it's going to, it depends on really the OS on how it chooses that first ephemeral port that it uses. But you know, it'll choose something. The ephemeral port is anywhere from 1024 through 65,535. So some of the OSs, like one of the examples would be it chooses a random number within there. And so let's just use a random number. Let's say it's 3045 that it's going to use. So this being sent here is going to have a source socket or IP / port number combination of this machine right here. And it's going to have a destination socket of this right here that's associated with this machine right here. So it knows the IP address of where it's going and the port or the service that it's trying to address. So that's what's going to be formed is this as the source and destination socket. The destination socket is so it knows what service to address, what server / service it's going to address. The source socket is so that way it can keep track of the conversation that it's going to pick up in the event where you have multiple, you're accessing the same web page or you're accessing the same service multiple times. So that is how the client-server relationship works between these two devices. And we can get onto those machines, and most machines have this, no matter what OS is running on it. And so you can get onto those machines, and you can type in netstat when you're in the command prompt. So as an example, Windows, you can go to the start menu, type in CMD, type in netstat, and then what you'll get is you'll see the actual open sockets that are open on here, and you'll see the local address, whatever it's coming from, right here, and whatever its destination is, what it's trying to access. So this is HTTPS, so the port that it's trying to access is 443. So same thing with this one is 443. So that's what it's trying to access right here. And you see several different combinations of that. And the TCP connection is established, so that is the little handshake that happens, the connection, which we will talk about in the future. But this is a way that we can actually see the local addresses, the destination, or the foreign address is what they're saying here on this machine right here. So go onto your machine, type in netstat, and see what kind of open connections you have. And on a Windows machine, it'll keep listing them out, so you can actually generate some traffic and go to a website and see how much of those TCP connections open up to establish that communication. It's pretty fascinating. All right, there you have it, ports. Pretty cool stuff, really. I mean, it's really amazing how ports will establish these connections, establish the conversation, and keep track of it all. It's just, there's an amazing amount of stuff that's packed in just what these ports do and how these ports function. So we talked about what is a port. We talked about those port groups and what are the well-known ports, the registered ports, and the private ports. Then we talked about port security and some different ways we can configure that, and the pros and cons of trying to implement that port security, and also hardening a box in reducing the amount of services a box has to reduce the amount of exposure that box has. Then we got into a socket, what a socket is. We talked about sockets as far as a source IP/port is concerned, and a destination source and IP is concerned. So we've got two different sockets within this communication that happens. And then we finish things up with talking about those ephemeral ports. Once again, the ephemeral ports are the ports that are randomly chosen or assigned somehow to the source side of this conversation that's happening to establish a communication channel. So yeah, just a lot that's packed into ports. They're pretty cool. It's kind of cool to see how ports kind of bring this all together to establish this communication. Hope these videos are helping you out. If they are, can you help me out by hitting that like button?